Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Well, hello and welcome to this week's episode of the DooDoo Divas Smells Like Money podcast. We have the distinct pleasure of continuing our visit with Tom Whitton of E2 Metrics. And today we're going to talk about PFAS. And Tom is going to be sharing with us some things that he has discovered, things that he's learned. And we're just going to have a discussion about this topic that in some ways has everybody in a panic. But I think if we approach this in a very systematic way, there are solutions. We normally talk about wastewater on the show, but we're going to be dealing a little bit more on the water side today in regards to this subject, but with that understanding that everything is in that great circle, that as Tom was saying to me, one man's wastewater is going to become another man's drinking water eventually, or irrigation water, or reuse, or however we're going about this. And so they are all interconnected. And with that, Tom, share with me a little bit about what you just learned and the discussions that you had in your meeting last week in Southern California surrounding this subject and what this could all mean for everybody, whether we're on the water side or the wastewater side.
We know that in the EPA just now, I mean, at the time of taping, 2 weeks previous to this taping, the EPA announced criteria for drinking water,
right?
For PFAS, for PFOA, PFOS, and then there's a calculation for 4 other substances, and ultimately it's like super low. Yes, these criteria are on drinking water, but at the end of the day, as you mentioned, I mean, if I'm discharging, wastewater to an environment, well, that becomes the source of water for somebody else, and so when I was in, Southern California last week, meeting with a number of utilities, mainly on the water side, it became pretty clear to me that this is a problem on the wastewater side because one district will discharge to a pipeline or to an aquifer that's being used to feed another district's drinking water, and so this is going to be a problem for the whole value chain, throughout water, wastewater. Also, the fact that many wastewater districts, they will also receive leachate, landfill leachate from. So rather than, it's a little more in Canada here. A lot of treatment happens on site for landfills, but in the U.S., it's for the vast majority of landfill leachate treatment, it goes to a POTW, and so in that, I mean, it's leachate is a toxic soup, and in that, any sort of consumer products, or frankly industrial products sometimes get in there too, which will leach these substances, from Gore-Tex, Teflon. I'm sorry for using these trade names, but I mean these are the ones that people more commonly know, and hopefully don't get a cease and desist letter from each 3M or anybody. But at the end of the day, these consumer products, these substances will leach into the leachate, and or through human use, when we wash our dishes, and they get into the wastewater. So it's going to be a problem for everybody, and so our approach to this is really looking at the solutions, not only from an economic standpoint, but also from a responsibility or liability standpoint in dealing with your PFAS in situ, including maximizing destruction on site at the point of capture. And I can get into that a little later on in our discussion.
Okay. So, from a technology standpoint, where do you see? I know you're making some inroads into this. So, obviously, the question why? Well, of course, because there's a need, but why this particular approach, and what would make it effective and sustainable as a solution? What sets it apart from other things that we might all have already?
Well, I mean, certainly, and when keeping with the market listening to this interview, um, you know, I don't think there are very many that are actually treating for PFAS right now.
Right.
The challenge is that when you have PFAS in the, say, 50 parts per trillion, like super small, 100 parts per trillion, getting that down to a level of, let's say we're talking for PFOA of 4 parts per trillion, which is the limit for drinking water for that was announced, at least the draft regulation from the EPA that was announced a couple of weeks ago. To get there, it's not going to be it's there from a cost effective standpoint, it could be extremely expensive. So we're of the position that you need to incorporate destruction, but you need to incorporate sensible destruction into any
Hmm.
sort of PFAS treatment. And here's what I mean. You need to be able to concentrate that PFAS, to make it as concentrated as possible before you do the destruction step. The reason for that is the more concentrated I can get the PFAS, by definition, it means I make my system small. I don't have to treat nearly as much volume. If I can get it to like 1,000-fold reduction, with all the PFAS being concentrated in say 1,000-fold reduction in volume, well then my destruction system, which I mean is illustrated, above my left shoulder here, these 8-inch diameter EcoThor electrooxidation reactors, they can then just destroy that small volume quite effectively, and that will then provide utilities with that peace of mind that they're taking care of what's going on in house. They're not relying on destruction using a third party. Having said that, um, when you are it's one thing to be able to get to 80 to 90% destruction, or get to 95 or 99 or 99.9. But to get that last little bit, your optimal energy consumption for removing that tiny last bit of that last tail is difficult. And so we're of the opinion that municipalities or operators, district operators will not adapt technology if it's too expensive. So you really need the concentration step, the destruction step, but you're not destroying it all. You're destroying the vast majority of it to then have a polishing step. So that polishing step could be granular activated carbon. It can be an ion exchange resin. And by doing that in that order, you're reducing tremendously the amount of adsorbing material that you're going to need. So you're reducing your cost between 80 or 90% compared to just absorbing the PFAS out of the water. So as much as we're the PFAS destruction people, it's really going to take an integrated solution. And where we situate right now is that we have a strategic partner for the U.S., actually for other markets around the world too. And this particular strategic partner, which, as I mentioned previously, was in the first taping, is it's not public yet. It may be public, maybe when this podcast gets published. So hopefully we can then put some links to that information. But this strategic partner, part of that relationship is that we'll be able to collectively offer that whole treatment train which includes at its heart a destruction step. Maybe one additional point is that the EPA has announced also that um, under CERCLA or Superfund
Mhm.
laws or regulations, PFOA and PFOS are going to, there's a proposal that they become designated as hazardous substances. I participated a couple weeks ago in a listening session with the US EPA, and they did say that municipal wastewater treatment stations and facilities are not going to be targets of enforcement. Having said that, I mean the whole concept behind these regulations is that if you capture PFOA and PFOS, you become responsible for that PFOA and PFOS, and you need to dispose of that accordingly. So certainly our position is that you need to have a destruction technology to be able to at least minimize your liabilities downstream, and certainly maximize taking care of the problem at the point of capture. You did just you asked the question, which I will just continue to expand on. There are other technologies for destruction. There are other players in the electrochemical oxidation or electro oxidation field, which is what this is, Ecothor AOP. Um, our position is that we're starting off with a commercial product, something that we've delivered already, and we're really tweaking it for PFAS destruction. So we're starting from a position which is very different, I think, than some of our competitors in electrochemical oxidation. There are other destruction approaches, but each one of those destruction approaches becomes more and more complicated. And so supercritical water oxidation as an example, where I just don't see in my head how a utility will have a supercritical water oxidation reactor on site, to have the people there to operate that, to monitor it. I just don't see it. This what we do can be operated remotely using our smartphone, and certainly this is certainly a huge advantage of having a simple process for treating and destroying PFAS. Sorry, I got a little long-winded
No,
there. I
no,
hope it
that's
was.
okay. So if I'm understanding you correctly, this is not meant to replace anything that a plant may have. This is something that is retrofitted and added or as a bolt-on just to
Absolutely.
deal with this particular issue.
Absolutely.
What's the
And there,
what's the
go
footprint
ahead.
on it? What's the footprint size on it, for instance?
Well, well, this image in my background and is in a 20-foot maritime container. We're
Okay.
still, I mean, one of the things, and let me talk about our project, which is right now at a southeastern US drinking water facility. Hopefully by the time we announce our strategic partner, we can also talk about the location of that. It is not a drinking water plant. We are effectively looking at the best ways to couple the concentration step, the destruction step, and the polishing step. So we're at the process of determining what is the optimal package. So what would be the optimal footprint? I mean, these 8 reactors, they this could be suffice for a concentrated, a 1,000 fold reduction and a 1,000 concentration of PFAS in a water stream. So this could be commercial scale. What's behind me, but it's really going to depend. We're with our strategic partner right now. We're working on what is that optimal coupling of each of the different steps, and certainly as we approach the summer months, we'll have a lot more information from a marketing perspective on this. But in the meantime, I think what's good is that we're getting that US experience too, which is where the regulatory drivers are. Canada, they're
Mm.
slowly catching up, but it's really US based, which is where we need to focus.
Is there
And,
any, right, that's okay. Is there any specific size of plant that this is ideally suited for, like a sweet spot where it can really make a difference, where it's going to be economically feasible? It makes sense.
well, this is always going to be an add-on, right? I mean, it's
Okay.
always going to bring costs. But when we were doing our economic evaluation of um, how much it would cost us to implement a concentrating, destruction, and polishing step, under the assumptions that we're reducing the media consumption by between 80 to 90%. Conservative will say 80%. When we look at the overall treatment cost for the entire plant, I'm not just talking about the destruction step, but the entire plant, it's less than a few cents a meter cube. So I guess maybe under well, 10 to 12 cents per thousand gallons. So it's
Yeah.
actually very cost effective. It's still going to be extra costs, and someone has to assume those costs, um, and that's, I think that's going to be part of the challenge too. Yes, on the drinking water side, the infrastructure bill that the Biden and Harris administration brought forth last year has $9 billion earmarked for drinking water applications. Well, you're going to need that kind of support, not just for drinking water. You're going to need that kind of support for all sorts of water, because you have an opportunity to capture this. As we said, somebody else's wastewater becomes somebody else's drinking water, and so that's it's all the same. And frankly, that's the certainly the influence of my visit to Southern California last week, was that philosophy is well ingrained in Southern California, with water reclaim and refilling the aquifers with treated wastewater, to refill the aquifers to become drinking water for somebody else. And so that philosophy, frankly, we need to have that philosophy everywhere. I live in Canada. We got lots of water up here, but I mean, I still think that philosophy and that approach makes perfect sense to do as much water reclaim as possible. Why should we be discharging to the environment and then taking upstream? And it does. I live very close to the St. Lawrence River here in the Montreal area, and of course, every municipality, as you go down either the St. Lawrence River or the Ottawa River, it's somebody discharges wastewater to it's been treated into the river, and then it becomes drinking water for somebody else downstream. So it's we need to be doing that too.
Well, let's talk about that a little bit in closing as our last thing, because, you know, there's water reclamation facilities all over the United States. I mean, it's becoming a really, really big topic. So, is this going to be of benefit beyond the PFAS? Is this something that could be very beneficial to existing water reclamation facilities in helping them be more efficient or effective in what they're doing?
Absolutely, because you're not going to be allowed to discharge or send back to aquifers PFAS laden water, especially with these new proposed draft regulations for drinking water. You're not going to be allowed to do that. So right now in Canada, there's what they call Title 22 water in California, where you can replenish as long as you get to that minimum standard. That's
Right.
fine. But PFAS is going to be a part of that, if not now, then shortly. And so it's going to be a necessity, in my view. And so what we try to do, where we're trying to position ourselves, is as a company, is especially with our destruction technology, is being at least a cost-effective solution. We've always come from anything that we do, whether we're any of our non PFAS, non-emerging contaminant related projects, we always come from the perspective of what is the economical solution, what makes the most sense. Where I profess to, I never want to push a technology on a solution. I want to, okay, what are the economics, what are the drivers, and then let's meet that, not push us as technology on a solution. And so that I think utilities, whether it's on the wastewater side or the drinking water side, will have no choice but to adapt. Because just to fall back on my trip to Southern California last week, I mean, there are aquifers that are an inland district will treat with a membrane technology, for example, and that concentrated solution, these what they call desalters, well, they're full of PFAS, and they get sent to somebody else, who then treats that as a wastewater, but then they want to reclaim that and send that back into the aquifers. And so it's complex. It's not, at the end of the day, I think mentally we've always thought about drinking water, wastewater.
Yes.
And I think we have to
Us and
stop
them.
thinking in those terms. Yeah. There's no us and them. I mean, it's one water. The water nexus. It's one, especially in the Western U.S. Mind you, they've had some weather recently, which has replenished a lot of the water. They're not. A lot of the drought areas have become less evident over the last few weeks. I had lots of rain when I was there last week, but ultimately, long term, we know that the level in Lake Mead is going down, which
Yes.
feeds basically Southern California from the Colorado River. And so all of this, and the aquifers are slowly getting lower and lower. So there's a real need to act, and there's a real need to do that. But we have to do that sensibly. We know PFAS has health implications, even in the parts per trillion level. If you listen to the EPA at the parts per quadrillion level, there are health implications. So I think there's no choice but to look at the whole thing from an integrated standpoint. You got to look at water, wastewater. You have to look at a complete integrated solution.
It's a great point. Well, Tom, thank you for sharing, your findings and those discussions at those meetings in Southern California. This is definitely going to be a topic that is going to still be at the forefront for a long, long time. And how are we going to deal with it? So thank you for sharing your insights. And I agree with you that it is one water. Absolutely one water. And so for those of you who have been tuning in and would like to know more about Tom's company and the technology that they provide, Tom, could you please give us the contact information now on where they can find you online to learn more?
So the company is E2 Metrics. So our website is metrics, metrix.com. And I could be reached via email at twhitton@e2metrics.com. So that's TWHITTON@e2metrics.com.
And you can also find Tom on LinkedIn and connect with him there.
Absolutely.
And so thank you again, Tom, for coming on the show. And thank you, listeners, for joining in and tuning into this very, very important topic today. And until next time, keep it flowing. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.